today, you will see something very similar for 2.4 and 2.5. 2.4, it talk about the infinite limit, okay? And then we are going to analyze the limit of the function as we are looking for the infinite limit. And what does it tell you from finding the infinite limit? What does it mean? I use this graph, and as you see, we have the two pieces of the graph. So you have the graph, the red curve, or the black curve here, and another black curve on the other side. Okay. In this section, the 2.4, we talk about the infinite limit, which is this part, infinite limit. What does it mean? The y value approaches infinity as x approaches a. Okay, that means that it's talking about this side. If you put in the limit form, limit of the y, which is the function f of x, as x approaches a, this is the value a, coming no plus minus sign. That means both sides of the both directions of the a, like coming from the left, coming from the right. The function value, that means both graph, the left and the right graph here. The y approaches this vertical line, or if you keep going, you're gonna get the curve like go further up more and more and more. That means it go without bound. That means the function y or the y values approaches infinity in the positive direction. But if you have the graph that it's approaching down to the bottom here, okay, that means if this is a point A, in this case, we use another notation as limit of the function as x approaches A, both direction equals, this time it goes all the way down, going to be negative infinity. So it depends on the direction of the function, either go all the way up or go all the way down. Use the plus or minus sign to tell the direction. Okay, either positive infinity or negative infinity. So this is going to be the case that we're going to look at for this section. Okay, could be negative infinity or positive infinity. And the point A, as the function approaches all the way up or all the way down, that point A gonna tell you something as the behavior of the graph. We're gonna cover it in a little bit. So the summary of the definition, the infinite limit, would be the limit of the function, which is the y value, okay, y value, as x approaches a, the y approaches infinity. So the notation is the limit, the two-sided limit, the function equals infinity. The limit is not always the same as the function value, so do not get confused. So the limit in general is the value of the y, which is approaches to or gets so close to that number. We know infinity is not the real number, that we can use for the limit value, but we cannot use for the function value because you cannot name any number as infinity number. Okay. All right. Similar to another case, like for the negative infinity. So this case, limit of the f of x as x approaches a, that means x approaches a, is negative infinity. That means y approaches negative infinity or go all the way down. Keep going down, further down more and more and more. Now, if you break it up into one-sided limit, it could be like 4 different cases. A, okay, for the first case, A approaches from the right side because superscript A, that means coming toward from the right side of the A, the function y value, the value of the function approaches infinity, so going up that way. For the second case, x approaches a positive, again coming from the right side of a, but the y value approaching negative infinity, so the trend of the graph going all the way down. And the third case, okay, the a here, coming from the left, the y value approaching positive infinity, so the behavior, the graph going all the way up. And the last case, as x approaches a from the left, okay, a from the left coming this way, and the y value coming toward the bottom or keep going downwards. Okay, as you see a as a reference point, either the function coming from the left or from the right, the graph approaching the vertical line, this vertical line is called vertical asymptote. For the infinite limits, you're gonna get the vertical asymptote of that function in the form of x equals a, because as a as a reference point, the graph either approaching from the left or from the right, all the way down or all the way up. Okay, one way or the other. Therefore, the infinite limit will tell you that a will give you the vertical asymptote. Vertical asymptote means the vertical line. Okay, vertical line. And the general form of the vertical line will be x equals the constant term, as you saw that in pre-calc. Do you guys have questions before I move on to the next part? No? Okay, no question. All right. If you have any question, just type in the chat, and I open in another window. I hope I can catch it before I go too far. Okay, and the next one, let's see the example by using the graph. Excuse me. The graph is provided. We don't need to know what the function is. So from the graph, this one is similar to the way that we find the limit value using the graph back in 2.1 or 2.2 as the idea of the limit. All the subproblems here, you find the limit of the function as x approaches 1 or approaches 2, either two-sided or one-sided, either from the left or from the right side. So let's do one at a time. Part A, limit of this function as x approaches 1. Number 1 is right here, but 1 from the left, okay? 1 from the left, that means you look at the graph and see where the graph approaches to as it coming from the left side of 1. Could you tell? It keeps going all the way up. That means the limit, the one-sided limit of the fx as x approaches 1 would be, keep going, would be positive infinity, okay? And then the next one, as x approaches 1 positive, still reference at the point 1, but now we look at the graph as x approaches 1 from the right side. Now we look at another piece of the graph. The graph also approaching positive infinity. So that's the answer for part B. Okay? Part C, no superscript. That means you are looking for the limit of the function as x approaches 1 from both directions. From A and B, it's already told you that both sides of the graph approaching to the same direction, which is positive infinity. Therefore, we can use infinity as the limit of the function as x approaches 1. That means two-sided limit. Both sides approach to the same direction, or the positive infinity direction. Okay, in part D, could you tell me is the plus sign or minus sign of the infinity as x approaches 2 from the right, because this is a superscript plus sign. What do you think? Is the plus or minus? You can type in the chat. I mean plus or minus infinity, because 2 is the reference point right now. So approaches 2 from the right, the graph goes down or up, positive direction or negative direction. Go ahead, type in the chat, plus or minus sign. That's it. That's what I would like you to see. Yes, it's going to be negative infinity. So thank you, Austin. So go all the way down here. So direction, negative direction. So negative infinity. How about the next one, part E? Look at the point 2 again, but this time it's coming from the left side of 2. The function approaches plus or minus sign of infinity. Plus infinity, very good, yep. And now can we say about the two-sided limit of this function as x approaches 2? What can we say about the two-sided limit of the function as x approaches 2? Is that positive infinity or negative infinity or does not exist? If it doesn't exist, just type DNE as does not exist. Or plus sign as positive infinity, minus sign as negative infinity. Yes, it doesn't exist because the left-hand side limit not equal to the right-hand side limit. That's the reason. Okay, thank you, you guys. Not too bad, right? So the way we, it's, I'm sorry, did Leah say something? Or
yeah, I said I have a question.
Okay, go ahead, Leah.
So when the, like, what we just saw in F, when the two limits are the same, it would always just be D and E?
If they are not the same, yes, we say the two-sided limit does not exist.
Okay, thank you.
Anyone else has question? That's a good question. Yeah, that's pretty much the one of the key of the limit. So if we say limit in general, that means we talk about the two-sided limit. That means the left-sided limit must be the same as the right-sided limit. If they are not the same, so even though we can find a value for both, but they are not coming to the same common number, so we say it doesn't exist, or DNE.